Hi, welcome to Physical Science 2.3c, more on linear collisions.
In a system, momentum is mass in motion, and we can apply our understanding of outside forces here as well. Momentum can only occur when there is an outside force or impulse, not from within the system itself. This important concept is called the law of conservation of momentum. It describes how when there are no external forces, the momentum of a system doesn't change. In equation form, momentum equals mass times velocity. To increase the momentum of an object, you need to increase its mass, its velocity, or both. This also means that different objects can have the same momentum. Say, for example, that one object is twice as massive as the other, but the second object has twice the velocity. For both objects, the product of mass and velocity is the same, so the momentum for both objects is the same. When this happens to two objects that are part of the same system, there is no net momentum. So we say that it is conserved. This means that there is no change in the overall quantity. If the momenta of the objects are the same magnitude but opposite in direction, there will be no change in the net momentum of the system. They cancel each other out, just like internal forces. Let's look at an experiment to see how this works, and understand in both the cases elastic collisions and inelastic collisions. First of all, we understand what is collision. A collision is an event in which two or more bodies exert forces on each other for a relatively short time. Here you can see that we consider two balls interact with each other. One ball exert force on second and second on first. That is collision. There are two types of collision: elastic collision and inelastic collision. Unelastic collisions occurs when two objects collide and bounce away from each other, are called elastic collision. The perfectly elastic collisions occurs rarely. Approximately we seen in the game of pool. And inelastic collisions occurs when two objects collide and do not bounce away from each other, are called an elastic collision, and they stick together. Now we understand the law of conservation of momentum in the experiment. According to law of conservation of momentum in collisions, the total momentum before the collision is equal to the total momentum after the collision. Then we say momentum is conserved. Now check it out in both the collisions: elastic collisions and inelastic collisions.
So let's look through several examples. Example 1. A moving toy car has a mass of 0.4 kilograms, moves to the right. It collides with a stationary toy truck of mass 0.75. After the collision, the two cars stick together and move together with a speed of 2.5 meters per second. So what type of collision is this? What is the momentum of the system, and what is the initial velocity of the car? So using 1, this is an inelastic collision. 2, the only place we have all of our information to find P equals mv is 1.15 times 2.5 is 2.578 kilogram meters per second. That has to be the momentum of the system. Then, setting up our algebra equation, mass is momentum divided by velocity. 2.875 divided by 0.4 gives the car an initial velocity of 7.1875 meters per second. Example 2. A 60 kilogram swimmer dives from a 200 kilogram raft with a horizontal speed of 2 meters per second. The raft is initially at rest. So we have a swimmer on a raft, and then we have the swimmer off the raft. So the type of collision, the swimmer and the raft together have a mass of 260 kilograms, and they're technically not moving. The raft is 200 kilograms, and we don't know what its velocity will be afterwards, but the swimmer dives off at 2 meters per second. So this is an explosion because our objects start together and then separate. The only place that we have everything for our information, P is equal to mv, is in the before. 260 times 0 is 0 kilogram meters per second. And then, therefore, we can solve our algebra problem of 0 is equal to 200v plus 120. And v is then a negative 0.6 meters per second. When you dive off of a raft, the raft goes backwards. Finally, a 60 kilogram blue ball going at 13 meters per second to the right collides with a 55 kilogram red ball going at 14 meters per second to the left. The balls bounce off each other. The blue ball continues to the right at 0.75 meters per second. So again, I have a blue ball at 70 kilograms, 13 meters per second to the right. A red ball, 55 kilograms, 14 meters per second to the left. They collide, and the blue ball continues to go to the right at 0.75 kilograms or meters per second. What happens to the red ball? We don't know. So what kind of collision is this? What is the momentum of the system? And what is the final velocity of the red ball? So this is an elastic collision because I have 2 before and 2 after. The total momentum of the system is in the before position. Notice that the velocity of the red ball is negative. So 70 times 13 plus 55 times a negative 14 gives us 140 kilogram meters per second. Using that information and solving that algebra problem, we get a velocity of the red ball of 1.59 meters per second to the right. Thanks for watching.